There are many ways to compare the healthfulness of different foods. One can compare nutrient content, for example. So if you were interested in antioxidants, you might compare vitamin C levels. If you did that for our two most popular fruits, apples and bananas, based on vitamin C content, bananas would appear twice as healthy, 10 milligrams in a banana compared to only 5 milligrams in an apple. But vitamin C is just one of thousands of different phytonutrients in fruits and vegetables. Turns out the vitamin C in apples accounts for less than 1% of an apple's total antioxidant activity. Here's the total antioxidant content of a red, delicious apple. Here's how much the vitamin C in the apple contributes. You can hardly even see it. Even though there's only 5 milligrams of vitamin C in a small apple, it has the antioxidant equivalent of 1,500 milligrams of vitamin C. I've reviewed before how taking that much vitamin C straight in a supplement might actually have a pro-oxidant effect and cause DNA damage. But you can get 3 times the antioxidant power eating a single apple without the adverse effects. Of course, there's more than just vitamin C in bananas, too. In fact, I was surprised to see the study out of Harvard suggesting that not only blueberries and strawberries, but bananas were significant sources of anthocyanins, the red, blue, violet phytonutrients found in berries. Maybe I underestimated bananas. They are, after all, technically berries. Still, I'm looking at these 3 fruits and I'm thinking, I see some anthocyanins here and here, but not seeing much, red, blue, or violet here. Now, wild bananas are a different story. There's anthocyanins in blue, purple, orange-red, red-purple, and pink-purple bananas, right? But none in yellow. So the Harvard researchers were challenged on it, and they said, look, we just took values from the USDA, and it turns out USDA apparently made a mistake. No anthocyanins in bananas, and despite twice the vitamin C, bananas were beat out by apples in terms of overall antioxidant power. But that's just measuring the ability of these fruits to quench an oxidation reaction in a test tube. It'd be nice to measure actual biological activity. For example, in this apple study, they also measured the ability of apple extracts from both peeled and unpeeled apples to suppress the growth of human cancer cells growing in a petri dish, compared to control. Wouldn't it be great to be able to compare that kind of superpower between different fruits? Well, now we can. Here's a graph of cancer cell proliferation versus increasing concentrations of the 11 most common fruits eaten in the United States. They decided to use human liver cancer for this study. If you drip water on these cancer cells as a control, nothing happens, right? They start out powering away at 100% growth, and they keep powering away at 100% growth. And pineapples, pears, and oranges don't do much better. Peaches start pulling away from the pack. At high peach concentrations, cancer cell proliferation drops about 10%, but bananas and grapefruits work about 4 times better, dropping cancer growth rates by about 40%. Red grapes, strawberries, and apples do even better, cutting cancer cell growth up to half at only half the dose. But these 2 fruits are the winners, causing a dramatic drop in cancer proliferation at just tiny doses: lemons and cranberries. So if you look at the effective dose required to suppress liver cancer cell proliferation, apples are more powerful than bananas, but cranberries win the day. And there was no effective dose listed for orange, pear, or pineapple, since they didn't appear to affect this cancer cell growth at all.